So where are we at? I've got my enclosure ready and it's time to go downstairs and install it. I am gonna learn something I didn't know before, and you, if you stick around, will get to watch me resolve the problem. So stick around. All right, so here we are in the basement, and this over here is the first sump pump that we're going to be working on. This is the electrical box that I set up originally. It's the one we're going to replace. It's crude. It's, you know, built off of version 0 of the code that I was doing, and it's been programmed with that Arduino IDE that I was talking about. So it's not sufficient, but it's got a power cord going to it that we're going to reuse. It's got the big battery bank here that we're going to obviously leave in place. So we're going to try to just swap this one out, even though I know it's working. Like, watch this. There you go. You can hear the pump working just fine. So that's going to move out that water. That's just me holding down my little manual button. And that's the process we need to be done all of the time. And I guess our backflow thing doesn't work perfectly. But anyway, let's just swap this out and be done in the basement. Okay, this is the best setup I think I can do so that you can see while I'm working. And we're going to try to just get this done in one quick push, because this has been a long process. There's a little blast from the past. I used to do a much better job of documenting stuff. So this is what's in that box, and I'll probably draw a drawing like this for the new stuff, but yeah. Also, here's some infrastructure from the home that's trying desperately to warn me whenever there's a water leak. So we'll get it out of the way. But this is from the home automation system too. It's supposed to find and scream at the house if there's water present above the lid, which there has been before. So yeah, scary stuff. I'm not happy. But let's start taking this apart. All right, and I think that is glued on there and soldered in there. So that's not coming apart. The first time you've seen it, this is the big relay. This is what turns the 3 volts into the 120 volts at high amps. So we definitely need that. And then, oh my goodness, I don't have anything. There you go. The ground's back. Oh, it's orange. Nice. And I guess we'll find out if I put more than one in. Oh, I only put one in. Convenient. Alrighty. So, nicely labeled. I've got pump power, and then I've got always powered, and then I had this is how I was powering the old stuff. So let's pull this off. That's the pump. We'll put that over on the pump. I've got wires and another. Okay, I can tell you right now, this is the float pump because it's got the big thick wire. So let's disconnect that. And then I've got screws, terminals for these wires. And I think I'll have to use my documentation to know what's what, but we need to take that apart. Screwdriver time. It's hard to tell which one goes to which ones. I think we're just going to undo all of them. Okay, so those are the floats. And this is the pump float, the one that comes with the thing that you buy. Okay, so we can move some things out of the way. How did I set this up? Oh, I've got that. Is that just loose in there? Oh, thank goodness, that's just loose in there. So let's undo those connections there. Okay, good. So we can pull that off. And then it looks like I've got to break into this guy. So let's unplug you. We are going to reuse some of this stuff, because why buy new when you've got readily good stuff. So there's a all-weather cover. Nice. Okay. Move that out of the way a little bit. So we've got some wire nuts. Got this wire here. Let's get, this is just the power cord for the ESP device. So we'll try to pull that straight out. Okay, good. So that came out nicely. Convenient. And I think the best thing to do here is to just undo these wire nuts, because we are going to do all of this over. Okay. Nice. Okay, so that frees up the outlet. And by the way, did you guys know that if you take this little bridge off of an outlet, you can have separate power for both upper and lower? Isn't that convenient? So I'm going to take the one off of here that says always powered, because we don't need that. We're no longer going to need power to our device through here. So we can kind of set that down for now. Okay, what are we left with? We have this cord. So let's loosen this, because I think this will help us get access to the screw. There we go. Okay, so there's our plastic thing there. I think now we can slide this out of place. And it looks like I just used a saw or a table saw or something like that. Okay, so this we can set aside for now. We don't need this one anymore. We got our upgrade. So this is really simple. You need to supply 120 volts there. This is the other side of it. It uses this 120 volts to help so that something as little as 3 volts can drive it. It's kind of cool the way it works. So very, very minimal amount of direct current is required here to drive this big relay. And I want to keep this. And I like the way I had done this in the other one, where in the case I had a groove cut out. We won't be able to do that outside. So that's something to consider. Also, this pump's only going to run for a few minutes at a time. We might not need as big of or as much of a heatsink, but I think it would be wise to try to keep it. So let's see, does that go through the first one? No, it goes through the second one. If we were going to try to duplicate this with this enclosure, we'd have a hard time sliding it through, because this does not have a zero lip like the other one does. So we need to think for a second about how we're going to do this. Maybe, I mean, we need to keep things enclosed. What if we hang on to this plastic thing here? We could probably put the outlet on a cover. I don't know yet. I'm going to face this same problem outside too. So let's just take off this heatsink. Okay, oh, that's probably some of that stuff. So that's going to get warm. We need to think about this. We know we want this new one installed in about the same position. We're going to need 2 screws, and we're going to have to drill holes through these guys, which is okay. I have drill bits, but I only have 1 screw. So let's drill out these so that I can use a screw like this. So somewhere around here is a 2x4. No idea which side, but if we do this, we're probably pretty guaranteed to hit the 2x4. Can't tell if we're in a 2x4 or not, but that felt like a good place to stop. And like I said, I'm just going to try to put one of these screws that was holding the cover on through the other side. Okay, That's adequate for our purposes. All right, we are going to start bringing our small time power in. And that's all of these guys. Yep, that's plenty long. All right, let's take some time and see if we can determine which one of these wires is the upper float versus the lower float. So, well, that's not very helpful. So because I took these off of the circuit board quickly, I don't get the benefit of their location and the color. So did I label the wires at all? The common one is green. That's well known. Are there any other labels anywhere? Shoot, I don't want to take the lid off of this thing because below there is very, very icky water. What to do? So I probably should not have disassembled this so quickly because now I'm left with a mystery of which one of those floats is the tall float and which one is the one that's at the very, very top. And I've got two colors left. I've got white and red. And so you know what I'm going to do? I'm going to make the assumption that I painted the one that's at the top red. That might be a silly assumption, but we're just gonna get this pump back into service. So once again, green, it goes in the middle. Okay, let's get some light on the situation. There it goes, solid. Tighten her down. And I'm gonna go with my gut here, and I'm gonna say that the red one is the emergency one, the one that we want all the alarms on. Actually, how come we're not hearing the alarm? We should have heard the alarm going off. Did I unplug it or not plug it in correctly? So, I unplug that. It should scream at us. Oh, there it goes. Okay. Turns out the polarity on those little sirens is, in fact, an issue. Okay. Good to know. Learning. Okay, that's done. The float ones don't really matter what side they are, but they do need to be loose. Ooh, we're gonna have to get our body a little bit lower so that we can see. Oh yeah, nice fit. Okay, those are all good. Okay, we have all of those connections made, so we can pull a little bit of this back out. That's probably good right there. So we have that float, and then this is the main float. Nice connector. Okay, excellent. So the sensors have all been installed. What's left now is the relay. And I haven't yet decided how I'm going to install the relay, but I know for sure that I don't need this chip at the back. And it would be really nice if the outlet could be in the same box as the relay so that I don't have, a third box. Because now we're just getting fat, You know what? Oh, battery. Is the battery gonna let me close this door? No, that's gonna hit the battery. That's a for sure. This isn't gonna be done. And I also think that there is a positive side and a negative side to this relay. So Input positive, input negative. Okay, so the white one is the positive one, and that's the yellow wire. So okay, so for a moment that's installed. So for the time being, and probably for a long time, I'm going to power this box with this cable here. Let's see. Inside of these is a rubber gasket. Oh yeah. Now we simply force the gasket over this and then force this guy up the hole. And we might have to withdraw those cables. All right, there's our power, and there's our other power. Did anybody else notice the big mistake I made? Behind the gasket has to go the nut. Put on the nut, then the gasket. Okay, so we already know this isn't permanent. Either I need a bigger enclosure because the battery isn't going to fit. But while we're thinking about it, let's plug in the battery. So now we have power to the little charger unit. And if it weren't for the fact that the battery hits this, which, you know, we could always just hot glue it somewhere else and close this. But for now, I'm just going to let it hook like that. So that's good enough for me. Now I have to remember one of these has power going in and one of them is the other side of that power. We know for a fact that we want the common and the ground on all the time. So we're going to set those on because that's obvious. Okay, all we are left with is we need one of these to go to one of these and the other to go to the other. So we've got a 50-50 chance that we get it right on the first try. So let's just try one. Okay, so we're doing this a little bit different than we did last time. We're gonna have to rewire this because this is not good to have your outlet like hanging on like that. All right, you know what we might have to do is we might have to drill out that hole that's holding the big nut and go ahead and just reattach this to it. And we can do that. We can do that later. But for the moment, before we plug anything else in, let's plug our pump in. Give power from the inverter instead of an outlet thing. So there'll be a power shutdown and then it'll come back on. See how that's now it's charging. It had reset what's in there. And this is the last piece. Now we're going to plug in power to the pump and the relay. And I don't see the little light on in there. Let's bump it. Nothing. Okay, we need to reverse the polarity. Okay, now when we plug this in, quick reset. Nothing. There was supposed to be something that happened just now. We've got voltage. Oh, you know what? We haven't plugged in the inverter yet. Boom. Now we have 120 volts. Boy, that was close. So, okay. Let's try it again. Oh, I hear it flushing. Oh my goodness. All right. So that means we're wired well enough for this to work now. I'm obviously not happy with the way this was wired. I need longer wires, and then I'm going to have to move this up like that. And we're just going to count on the fact that this thing doesn't run for more than 15 seconds. And we're gonna abandon the heatsink for now. maybe. I'm still not sure that's the best idea. I still think that it would be nice if I had an outlet here and the heat sink sticking over here, and this was just right here, something like that. And then that way, the only thing I have to send over here is 3.5 volts. So I think that's what I'm going to do to make this all work. I'm going to put that in there like that, or like that. I can't remember how it was. It was something like that. That setup seems like it's a really good setup. So I have to take some time to, you know, cut the holes so that they're in the right place. But we'll just have a cover like this. If I can cut around it well enough, that'll look really good. And then 3.5 volts comes in, 120 volts comes in, and then the plug for the pump is right there. So I don't like how it's not done, but at some point I need to move on to the one that's outside because it's way worse. So let's test it by running some water to make sure that it pumps on its own. That's, you know, normal operation is the most important thing. So this is going to be boring. Something is very wrong. That's not at all what that thing is supposed to sound like. So now I have a full sump pump, and if it didn't flow out like it's supposed to. So let's see if maybe the polarity of this does matter. No, because it turned on. What would changing the polarity of the relay do? We were given we sent instructions, run the pump, but it just sat there and shook. Let's plug it back in and see what we got. Now that's it's still on now. Oh shoot! I need my phone to diagnose this problem. I need to go visit the site and see which one of the floats it's saying is telling it to go and why it's still on. Or maybe I need to bring my tester thing down here. But actually, let's undo this float, this connection here, and plug it in and see if it comes on. No. So it's definitely this float. It's telling it to go on. That's dry in there. Did I accidentally run this thing a little bit too low and let the float get goofy? This went from a perfectly working system to now it has pumped well longer than it should have, and now it's dry in there. How did I make what's in that box worse? So we didn't, other than letting it run dry a second ago. So let's bring some more water in and we'll see if the other floats catch it. I don't like where I'm at. This is not comfortable. Not where we were supposed to be. So this is uncomfortable territory. I've disconnected the float that's connected to the actual sump pump. And I'm now basically testing to make sure that the other floats work. And I guess to some degree I'm testing if I got the correct order of floats. And if I didn't, we'll hear an alarm before we hear the pump come on. And that'll be my sign that I need to switch those two wires out. So we won't put the screwdriver away yet. And maybe we won't put the glasses away yet. Where's the flashlight? Tweezers, that's what I want, is my tweezers. There they are, they're already out. So, not a comfortable place to be at all. I also don't have any indicator LEDs on the screen or on the device, and it's because I don't want to be looking at these devices ever again. But something is definitely not happy in the sump pump, the float is out of place, and maybe if we let water come up to these floats, the other ones that are on the door. Sorry, I should show you these ones. If I let the water come up to these floats, it should kick off, and if we hear the siren, then we'll know that I've got the floats backwards, because we don't want to hear the siren. So this is kind of scary. I'm gambling with a water leak here, and that's not comfortable ever. If I do see water, I'll hit the manual button, but I don't think I will. The lid floats should get us first. It's taking an uncomfortably long amount of time. It's kind of nerve-wracking, sitting here knowing I'm flowing water into a bin that has excrement in it, and I'm not letting the normal process take its course. I'm waiting to test my goofy float ideas. This is kind of uncomfortable. At least we know once it's properly emptied, it does take a long time to fill up. So that's good, right? Yeah. Oh, cow, how much water can this thing take? Okay, it kicked on. Oh, thank goodness. Now let's put this back on. Because with this on, it'll shut off my automatic timer early. Like as soon as this float says I'm done, it'll shut off the pump. And we're hoping that it runs and then we don't hear the pump run dry before it stops. And I didn't hear the alarm, so we got the ordering correctly of the two floats. And it's still running. The float is trapped up, and that's stupid. It shouldn't be, but it's trapped in the up position. That means I need to take the lid off and inspect. Ugh, goodness, I was hoping to avoid getting into that because it's stinky. Yeah, it's just shoot. Is it possible I'm misinterpreting this thing's open for close? No, there's no way. That can't be. This thing's turned on. Yeah. Oh my gosh, we're gonna have to open the trap door. Oh, yuck. Okay, I just want to acknowledge I did manually empty out this sump pump, and it's possible that the lid, the float, somehow got trapped. But in the on position, that seems odd that me draining it would have it trapped in the on position. So I've brought down just some cheap multimeter, and we're gonna just test this to make sure that I didn't mess it up. And maybe there's a signal coming off of this that's just the right amount to trip that input into thinking, hey, something's wrong. So, well, let's give that a chance. Maybe this float's got a charge to it. That doesn't make any sense at all. But we used to run, I think, 5 volts coming out. No, maybe it was 3 because we didn't have any other source going on. So anyway, we're just going to turn this on. We're going to turn it to the yell at me if there's connection, which is right there. We'll test it out with this, screams, and then we will stick. Oh my goodness, it's not screaming. Something is off in my chip. I did something here. So let's see. It has ground. It's got signal and hot. Let's change this to volts. Let's just test across the hot here. So if I connect to the ground coming in, so that guy right there, and then I connect to this ground over here. Are you hearing that? It's sending some kind of signal. This is wild. Why is it doing that? Okay, that's what I would expect when you close it, but not when you put something that isn't closed on it. Okay, this doesn't make sense to me, but let's just reverse the polarity of those two wires that are going into the box. That doesn't make sense to me, but we're going to try it because that takes less time. But what on earth? Why is this closing? Whoa. That is the most sensitive input. It's almost like it's not grounding. It's almost like it's not being pulled to ground. Like maybe there's a bad solder joint right there. Boy, this would be bad timing for that. I just installed the thing. I think we're going to have to take this apart and check the solder joint because it's not acting right. Shoot. It happens to all of them. What is going on here? It's almost like this ground wire is not connected properly because all these inputs are acting. Holy cow. We didn't expect that. Oh, shoot. All right, we're pulling the plug on this. I've got to take this back to my office and see if I can find out what's going on. Between now and then, this basement can't run any water to it, so that's good because no one's staying in the basement. Oh, and I have to disconnect those. Those are the only ones that seem to be working correctly. These other ones are overly excited. Let's see, can I turn this off? At least you guys are getting like the honest experience. You're not getting a sugar-coated, everything worked fine the first time version. I have to chuckle because my father-in-law was visiting and I was telling him what I was doing and he was asking, is there any way you could like patent this and sell this? And my answer to him was, no, this is a hobby. Most people just install a sump pump and let the float work until the float dies, which it eventually will die. Eventually that float will fail in the on or off position. And I don't just mean by floating. Sometimes the wires inside of it, because moves so much, and because you're sending all of the amps through it, it'll die on you. And that's what happened to me. That's why I'm doing any of this, is I need a guarantee that if the mechanical float that's been put there by the manufacturer fails, that I have backup floats that will take care of business and alert me to the situation. But also, I needed something that's giving me a little bit of monitoring. Like I would like to know if the float's been on for the last 20 minutes. Like I think that's valuable information. You don't get any of that, especially when a float's installed outside of your home. You don't get any of that from just having a mechanical float in place. So this is partly because I want monitoring. It's partly because I don't trust the float. And it's partly because this is a hobby of mine. My first guess here, my finger should not be producing enough electricity to rise these from ground to high. Like that shouldn't be happening. My hope is that it is as simple as the soldering job to the ground didn't work correctly. So there's a gap, and these ports are not being drawn to the ground with enough voltage that they can be easily accidentally powered. So to test this, we're going to supply power. Kind of freaked me out when that float was causing it to stay on. And the sound that it made that first time was the pump sounded like it was not working correctly. And now that I think about it, I think it's because it was being taken high, low, high, low, high, low, high, low really fast by that relay. So let's power this on. Okay, so now the ESP has power. I'd like to see what's happening. So I'm going to log in to the computer here. And how are we going to monitor that the relay is on? So Sump inside. Just do a little refresh. Okay. Oh yeah. Let's see. We need to ground these guys out, or else they'll stay on the whole time. Where did my wire go for that? Please hold. Let's just put floats on it. I've got these in my office. I may as well make use of them. Okay, good. The website says that one of these turned off. That's good. And the website now says that both of these turned off. That's fantastic. And my finger on those doesn't matter. Huh. Okay, and then I think an LED. These are supposed to be 3-volt LEDs. Let's test that real quick. Steady on. There we go. So that's a 3-volt LED. So we'll put the LED in there. That'll be our is it running or not tester. Okay, so if one of these comes up, that should go on. Okay, sweet. Could it be that the presence of 110 volts was messing with these? Because if I plug in my logic tester, I'm fairly certain that this does go to ground. I wonder if we want to keep that 120 stuff way away from all of this stuff. Yeah, that's low. That's low. That's reading low. That means it has a connection to ground. That's low. That's we expected that. So that is our input to the float. It says low. You know, do we need to keep that relay as far away from our stuff as possible? That might be the key, is that we should be using that distance between here and the big relay as literally a get out of my business and stay away from my stuff. But honestly, that float thing, if it can trip this, it's got to be something with the solder joints. So I'm going to put on the glasses and we're going to flip this thing over and we're going to try to do a nice inspection. Okay, when we were downstairs, simply touching this input with my fingers was enough to do this, to get it to go, and there's nothing like that happening. So I think we know what we're going to do. We're going to take this back downstairs, we're going to assemble it just like we had, and we're going to make it so that the 110 volt stuff is adequately far away from our input. That's kind of a disappointing bench test find. Hey, you can't run this thing next to where it needs to run. That's kind of sucks. So, okay, let me take it back downstairs. Okay, as I was coming down the stairs, I had to ask myself, was I bringing everything with me that would change the outcome of this experience, of what we're trying to do here? And I believe the answer to that is now, yes. I believe I have brought with me enough things that are going to allow me to do this one more time and be done, and that it will be successful. So here's what I'm going to do that's different. The relay is going to be driven in a completely different location from this long wire. So this long wire, along with my charging cable, are going to come in here. Okay, good. So the charging cable has to come up and it wraps a little bit. This other wire is the relay wire, and I need my tweezers already. So black to ground, yep, that's easy. Red to positive, easy again. While we're here, let's put the power back in. So once again, red to the red, neutral to the, or sorry, negative to the black post. Very good. May as well. Gotta try not to steal other people's sayings here. This one, it might be easier if we get a little bit closer to it. And if we remember correctly, the red wire on the tri-wire here is for the highest bubble, or highest float. Okay, so you guys come in. You have to go past that gasket first. We'll pull you all the way in for a second. Okie dokie. Let's do you first. So the regular float goes in. Haven't tightened any of these yet, so we're just kind of hoping we can do all that at once. This should be fast. I brought everything but the screwdriver. Okay, give me a minute. I'll be back. That's kind of funny. It's been one of those days. Found it right up there. Okay. And I think what I'm going to do is I'm going to add the LED back into the mix here. But first I'm going to tighten a few of these. So the power looks good. Let's tighten it. The float sensor looks good. Let's tighten it. Before we tighten the I want to see like before we get to the power. Okay, well, stop. Okay, relay wires. That's all. Last that we do is our common was green. The low was white and the high was red. Okay, no problem. Those all went in nicely. Okay, I'm going to plug in this power source here. I'm going to withdraw these sensor wires as far as I feel like they need to be to feel good in there. That feels about nice. That makes a nice clean setting. And I'm going to tighten them down. I'm going to tighten this too. Okay, let's power this thing back up. Battery. And let's plug this guy in here. Okay, a little long, but it'll do. Okay, and turn it on. All right, that thing should be working now as designed, and since we don't have a big relay in the way, we can even close it. Now the question is, if I reconnect the float, will it send 3.5 volts? Oh shoot, those are touching. Dang it, that was bad. Are you on or are you off? It's on. Son of a gun, what is the difference? Now it's shaking, it's pulsing, because it doesn't know. Something is goofy. Do I need a stronger, like we're not even connected to any. This is so wild. Why is this happening? And then if we unplug this, it's off. Oh no, it's not. There's a little tiny bit of voltage going to it. Just a minuscule amount. Turn that on and it's full. Turn it off. Turn it on, turn it off. Move my hand around. This wire is kind of annoying. We can unplug it. We'll go on battery power for a second. Actually, how far away from this can we put you? That was not a good sound. Okay, on, off. Okay, my finger's not doing it this time. Let's see if I... Okay, that's not working. Last time, and I just touched these screw terminals. It came on. But for some reason, when it goes out through this wire, it gets angry. Oh, not anymore. Let's see. Oh my goodness, look at that. It's an insulation problem. Let's pull it off the wall. There's nothing that says it has to even be on that side of the room. And let's try to have it intersecting with the power as few times as possible. I'm kind of frustrated. This system is a lot more delicate to fluctuations of voltage than, or sorry, noise. I'll just call it noise, than the previous system. And maybe those resistors that I have to my ground, maybe they're not high enough. Maybe they need to be much higher. If we have interference problems, I may have to go back to kind of the design board here and build this with better noise what do you call it? Isolation, because we cannot have false positives and we definitely don't want false negatives. We do not want this system thinking that everything is just fine when in fact we are in trouble. So, okay, 110 is on this side of the room. Okay, let's do a test. Absolutely, still feeling a jolt of electricity. I mean, technically I can run the system off of the floats that don't seem to have this problem. They've been washed. Or maybe the problem is that they're always on. And because they're on, it's got a solid 3 volts coming into this. And because it has a solid 3 volts coming into this, it can turn it into 0 volts correctly. These ones, let's get the old probe out. I brought the probe thinking that we might need it. I might have been right. Oh, it's screaming. Why are you screaming? Wow. Why is there so much noise? Listen to that. Now it's gone. Now it's back. No, 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 no. It's ebbing and, oh my goodness, is it the hot water heater? Let's turn off the hot water heater and see if we're getting screaming electricity from that. Okay. I don't think it's the hot water heater anymore. Okay, so that's the hot water heater turned all the way off, and we're still getting that noise coming through. Okay, so that's not it. Is it the inverter? It's absolutely this inverter. Holy cow. I would have never in 100 years thought that that would be the reason that this room would be so full of noise. is this inverter, but clearly it is. So I need to move this somewhere else. This is crazy. Okay, well, where are we going to park it? This is pretty far away. Okay, let's see if we're picking up ET again. I'm not hearing ET. You guys hearing ET? Oh, man. Well, let's just keep going then. Right? Soldier on. And let's do a test. Let's get some water flowing. So let me aim you back over there. Okay, we're flowing water. Boy, I'm glad I did not open the lid of this thing just on a discovery mission, because it would have been a waste of time, and it's stinky in there. Okay, come on. We're sending water. That was weird. When I had that wire in my mouth, I could actually taste a tiny bit of electricity, and then when I turned it on, for sure, I could taste more. But yeah, the whole time it was on, I could feel it. That was weird. Battery's nice and full. There it goes. Beautiful. And it's off. Success. That's what we're talking about. Holy cow, that was hard. What a disaster. That didn't go to plan at all. Like, that was supposed to be an example of here's how to do it. Watch this. Didn't go that way at all. I don't know how much of this to include in the film. I don't know how interesting it will be to watch me make mistake after mistake after mistake, or have things go wrong. I don't know if they were mistakes necessarily. To me, they felt like mistakes. So I don't know. I think I want it in the footage, because if you're having problems like I have, now you'll know, hey, use a tool to detect noise in the air. I don't know. The good news is in the outside area where this has to be installed, the inverter is already really far away from the power for the pump. So we won't have the problem that we would have outside. But yeah, I don't know. That's a really long video of something that, I mean, I was just replacing the one that was working. I wasn't even replacing the broken one. And the fact that it was working before I replaced it, that little ESP must have been living in hell, that's still doing its job. So yeah, shoot, what to do. Okay, well, that's where we're at so far. Outside will be next. I'm at the end of this video and I'm thinking, this is pretty long, let's cut it out. In case I didn't actually say it, I'm dealing now with electromagnetic interference, EMI. It's the stuff that comes off of all of our power lines They all run at this 60 hertz, which means they're going like this, I think 60,000 times a second or something like that. Sorry, I don't know. And you can hear that. You can sense it with some of your devices. I've got a signal tone generator for running Cat5, and on the other side of it, it's got this microphone basically. And what it does is listen to EMI created by the tone generator, and you get a wee, 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 wee sound. Well, anyway, that DC battery and the inverter created a tremendous amount of EMI. So much so that across the room, that length of wire, it is pretty long, I'll give you that. But while this wire is in the presence of it, if the wire's long enough, it's gonna pick up that signal. And it was enough to trip the chip into thinking you went high. It wasn't the ESP though. It was the little integrated circuit that had the cascading set of OR gates. And so with some consultation with AI, I had to re-engineer the input lines to be less sensitive to that stuff. So rather than having a single pull-down resistor, I now have a series. I have a 1K resistor straight off the port, then from there, a 10K pull-down with a capacitor, and then after both of those, then it goes to the input into the chip. I think I also had to buy a different chip. I think that would make a good separate video, something that's all on its own. And so I'm going to call this one at here. As always, I'm very thankful for those of you that watch and pay attention. I hope my mistake can benefit you to where you don't have to do the same thing. So I'm going to create one last video. I've got a tiny bit more footage of me deploying this chip downstairs. I got some video of me experimenting with the interference. It's actually kind of interesting. It's only on the DC side. The AC side is fine. So if I use a dongle to plug into that wall jack that's on the back of the inverter, it's clean. But if I plug directly into the inverter's USB ports, noisy, noisy, noisy. So I have some footage that does all of those things, and I don't know how valuable that stuff will be. But I definitely think talking about the different chips that I bought, and these are the integrated circuits, the little ones, those were important so that they don't accidentally trip on their own. And then the addition of that extra resistor to try to calm that interference out. I think that would be good for another video. So this is part 3, and it's mostly me finding out about EMI. So, you know, I'm sorry that it's so long for me, but I spent a long time finding that problem. I'm not kidding. It took me forever to find out why that problem was happening. So you got to see a little bit of that. But stay tuned. I am going to do a part 4 where I explain the circuit a little bit better and what was done to fix the EMI. Everything's been deployed. So I'm in post right now, and I'm very pleased with the additional things I did to the chip. I now have a visual indicator that says this chip's healthy from 100 feet away. So, okay, thank you all very much, and have a great 4th of July weekend is when this is going to come out. So actually, I think the other one's coming out. Anyway, I'll try to get these out kind of quick together because they're not really tractor work, and that's what we want to get back to. So thank you all. Have a good night.